This video is for Math 70, and this is part 2 on trinomial factoring. So, quick review. In part 1, we talked about factoring an expression that had a plus sign in front of its last term. And that told us that we wanted to find factors of 10 that added up to be 7. And whether that was a plus 7 in the middle, right, with x squared plus 2x plus 5x plus 10, or whether you had a minus 7x in the middle, that would give us x minus 5 and x minus 2, we still get a plus 10 at the end because negative times negative would give us that positive there. Okay? So, in this assignment, we're going to look at what happens if we've got a trinomial expression where the last term has a minus in front of it. So, for example, x squared plus 3x minus 10. Okay? So, what that minus 10 is telling us is that inside these parentheses, we're going to have opposite signs. 1 plus, 1 minus, because that's how you get a negative answer, is by multiplying positive times a negative. So in this case, what we're saying here is we need factors of 10 that are going to have a difference of 3. And of course, it's still 5 and 2. X plus 5 times x minus 2. So there's our x squared minus 2x plus 5x minus 10. And there's our plus 3x in the middle and the minus 10 on the end. So that's the key here. The next assignment will mix these together, and you'll have to decide whether you're looking to do this or whether you're looking to do this. Okay? But for today's assignment, they're all going to have that minus sign at the end. So we're looking for factors of this constant piece, this last numeral here, factors of this number that have a difference equal to the middle number. Okay. So let's see here. Problem 2, y squared minus 3y minus 4. So the minus sign tells us we want factors of 4 that have a difference of 3. So 4 and 1, right? 4 times 1 is 4. 4 minus 1 is 3. But we want a negative 3 out of this. That means the 4 has to be negative and the 1 has to be positive. So there's our factorization. Problem 4, we've got a squared plus 2a minus 8. So the 8 could be 1 times 8, or it could be 2 times 4. These would have a difference of 7. These have a difference of 2. Those are the ones that we want. So the 4 and the 2. And because this is a positive 2a, we want the 4 positive, we want the 2 negative, and there's our factorization. Problem 6, x squared minus 10x minus 9. So the 9 could be 1 times 9 or 3 times 3. So these have a difference of 8. These have a difference of 0. None of them, neither of them, has a difference of 10. This one is prime. And again, I don't do that very often, and I don't do it at all on quizzes and tests. But keep an eye out for those as you're working through these problems. All right, let's see here. Let's look at problem 10. Here we've got a squared plus 7a minus 18. So, if we look at the factors of 18, right, you could have 1 times 18, 2 times 9, 3 times 6, 4 and 5 don't divide in, and so that's it. Okay? So, these have a difference of 17. These have a difference of 7. These have a difference of 3. So this is the one that we're looking for, 2 times 9. And again, if you just recognize that right away, you don't have to analyze all the possibilities. Just go to the one that's going to give you the answer. That's fine. I'm doing this to try to give you a complete picture of what's happening. So hopefully can help you to better understand what's going on. So again, we found those two factors. 2 times 9 will give us the 18, and 9 minus 2 is 7. So if we're getting a positive 7, that means we need the 9 positive and the 2 negative, and there we go. Okay, well, let's see what else we've got here. Problem 14. What do we have here? Q squared minus 16Q minus 40. So let's see here. 40 is 1 times 40, 2 times 20, not divisible by 3. 4 times 10. 5 times 8, 6, and I think that's it. Those are the factors. So let's see. And if any of these have a difference of 16, this is a difference of 3, difference of 6, 18, and 39. So this one is prime as well. Okay. Let's see here. Now you have the answer key for the odd problems, and you can see that only one of them is prime in the odd problems. Okay, so don't just fall back on that because you don't want to try all of the possibilities. Let's see here. Let's look at problem 18. So in problem 18, we've got y squared plus 9y minus 7. Okay, so what are the factor pairs for 70? You could have 1 times 70, 2 times 35, divide it by 3, divide it by 4, you don't get whole numbers. Divide it by 5, it's 5 times 14. And let's see, 7 times 10. But I think that's all of them, okay? And again, notice that as this number gets bigger, this number gets smaller, and then after they meet, then you can stop, right? Because the next, it's not divisible by 8 or 9, and then the next pair would be 10 times 7, which we already have, okay? So, this pair has a difference of 69, this pair has a difference of 33, this pair has a difference of 9, and this pair has a difference of 3. So here's the one we're looking for, 5 times 14. And so we'll put our numbers in there. And let's see, we need a positive 9, so we want the 14 positive and the 5 negative. All right, now down on the bottom of the page here, let's see, problem 20 says find all positive whole numbers k for which the given trinomial y squared plus k times y minus 20 can be factored. Okay. So this is where we do actually need to look at all the factor pairs. So like I was saying before, if you know the one that's going to give you the answer right away, just use that. You don't have to worry about these other ones. In this problem, all of them is the whole point, okay? 20, you could have 1 times 20, 2 times 10, or 4 times 5. Let's see, 10 minus 2 is 8. 5 minus 4 is 1. So, for this to be factorable, k could be 19, or 8, or 1. All right, let's look at a couple more of these. Problem 22, m squared plus k times m minus 36. So let's see here. 36, our possibilities are 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. So this one would have a difference of 35. This one has a difference of 16. This one has a difference of 9. Difference of 5. And here the difference is 0. Okay? So, and for 22, k could be 35, 16, 9, 5, or 0. Alright. Now the ones on the next page are similar to this, but they're a little bit different. We move the k from the middle to the end. And that changes how things work a little bit. So, for example, 24, we've got y squared plus 4y minus k. Alright, so here's the thing. And I say this in the instructions, there are multiple solutions to these problems, starting with 23. Okay? So the idea is that we want two numbers whose difference is 4. So, you could do 7 minus 3 is 4. You could do 9 minus 5 is 4. Okay? And let's see. I think I'm only asking you for 2 possibilities, right? So, if 7 minus 3 is 4, then we could have y plus 7 times y minus 3. This would make k equal to 21. So 21 would work because 7 and 3 have a difference of 4. Down here, you could have y plus 9 times y minus 5. That would give us a difference of 4. And in that case, k would be equal to 45. And we could keep doing this. Like I said, there's, actually an infinite number of solutions. Right? You could just keep doing this, raising this number and raising this number by the same amount and keeping that difference at 4. And then when you multiply them together, you get the value for k. All right, let's look at one more of those. Let's see here. Problem 26, m squared minus 7m minus k. Okay, so we need a difference of 7, so we could have 9 minus 2, 10 minus 3, 15 minus 8, whatever we want to do here. So this, let's say if we had m minus 9 times m plus 2, that would give us the negative 7 in the middle, and that would make k equal to 18. 9 times 2 is 18. Or let's say we did m minus 15 times m plus 8. That would still give us a negative 7 in the middle. And here, k, I think, would be 120. 80 times 15 would be 120. Okay, so that's all the work we really need to do on those last couple of problems there. Like I said, you can keep going with this. There's an infinite number of answers, but we just need to find 2 of them and leave it at that. Okay, so this is part 2 of trinomial factoring. Like I mentioned at the beginning, the next assignment will put these 2 parts together, and you'll have to decide whether you're looking for factors that have a difference equal to the middle number, or if you have looking for factors that add up to give you that middle number. And so I'll talk about that in the next video. As always, if you have any questions, please let me know. Thanks.